The global tower crane market is valued at around $5.5 billion. These massive structures, which can reach heights of up to 100 meters, are built to bring human ingenuity to life. But how are these colossal cranes made? To find out, let's visit a factory specialized in the construction of tower cranes and explore the process. Tower cranes have their origins in the early construction methods of ancient Greece, where pulley systems and other simple tools were used to lift heavy materials. However, the modern design of these cranes began to take shape in the 19th century, driven by the Industrial Revolution, which brought advancements in steel production and the invention of steam engines. This enabled the creation of larger, more powerful equipment. In the early 1900s, a German engineer named Julius Wolf built one of the first modern tower cranes, marking a significant leap in construction technology. Throughout the 20th century, these cranes continued to evolve with the addition of electric motors, hydraulic systems, and a more modular design. This made them indispensable for constructing skyscrapers and major infrastructure projects. But what kind of work goes into building these enormous structures? Before installing a tower crane, it is essential to properly prepare the site where it will be placed. This process starts with a detailed soil analysis carried out by specialized engineers. They must ensure that the ground is firm enough to support the crane's weight and the loads it will handle, which can range from 1 to 20 tons. The study includes strength tests, settlement assessments, and, in some cases, ground reinforcement if the soil does not meet the necessary requirements. Once the ground stability is confirmed, construction of the base begins. A reinforced concrete slab is poured, anchored with steel, to provide a solid foundation for the crane. This ensures stability even under extreme load conditions or severe weather. The base must be robust and perfectly level to prevent tilting, which could compromise safety. The curing process for the base can take anywhere from several days to weeks, depending on the size of the slab and weather conditions. It is crucial that the concrete reaches its full strength before the crane assembly continues. So, where are these cranes actually made? The manufacturing process for a tower crane begins in specialized factories where key components are produced, such as the towers, booms, and slewing supports. These facilities also handle the initial assembly of the basic control systems, preparing the parts to be integrated into the final structure. Some components, such as electronic systems, operator cabins, and control panels, are manufactured at other production facilities, often in different countries. The base material, usually metal, first goes through a polishing process to remove impurities and prepare the surface for the next stages of production. The pieces are then cut, processed, and assembled on a welding line where the structures are built with precision. Depending on the technology used, the welding process is carried out either manually or with automated robots. Once the main structure is assembled, it is moved to the painting area. Here, a multi-stage process takes place, including surface cleaning, the application of an anti-corrosion primer, final painting, and drying. This ensures that the parts are protected and ready to withstand the harsh conditions of their working environment. Before the crane can become operational, it undergoes rigorous testing. Technicians check and connect all systems, simulating their operation under real-life conditions. These tests include load handling, rotation, and movement of all mobile parts to ensure that every mechanism operates safely and efficiently. The entire manufacturing process of a tower crane, from metal processing to final testing, typically takes about 30 days. Once completed, the crane is disassembled into sections and transported to the construction site on specialized trucks. Since unlike mobile cranes, tower cranes cannot move on their own. When the concrete base is ready and the crane parts have arrived on site, installation of the first section of the tower begins. This key piece houses the slewing mechanism, which consists of motors and mechanical systems designed to allow the precise rotation of the structure, even under demanding conditions. Installing this part requires exact alignment to ensure smooth operation and to prevent any strain that could compromise stability. During assembly, specialized technicians carefully verify that all gears and connections are properly installed and aligned. They also ensure that the electrical and mechanical systems meet all required safety and operational standards. The tower is assembled in several stages using an auxiliary mobile crane to lift the sections. The first sections of the tower are placed on the slewing base and secured with bolts and supports to ensure stability from the very start. The tower is then progressively raised by adding new sections one on top of another. Each section is securely fastened with high-strength bolts and clamps, keeping the structure firm as it gains height. The process continues until the desired height for the crane is reached. To achieve greater heights, a climbing system is used to add new tower sections vertically. This system features a hydraulic cage, known as the climber, which is installed on the tower structure. The hydraulic climbing cage lifts the top section of the tower, creating the space needed to insert a new section. Once the new section is in place, the climber adjusts to secure it and maintain the stability of the structure. This process is repeated step by step, progressively raising the crane until it reaches the required height for operations. During the climbing process, the top of the crane acts like a giant balance. If the center of gravity is not properly aligned with the lifting system, the crane can become unbalanced and collapse. Additionally, the climbing frame is not designed to withstand strong torsional forces, so it is crucial to keep the crane perfectly stable. To minimize risks, new tower sections are placed straight on the ground, eliminating the need to rotate the crane during the process. Once the tower is fully assembled, the main jib is installed. This is the horizontal structure that extends from the top of the tower out over the work area. The jib is responsible for carrying loads during crane operations. It is mounted using a system of cables and anchors, making sure it is securely fixed and properly aligned for optimal performance. To balance the jib and the loads, a counterweight is installed on the opposite side of the tower. Typically made of concrete or metal blocks, this counterweight helps maintain the crane's stability by offsetting the weight of the jib and the loads being lifted. Proper installation of both the jib and the counterweight is essential to ensure safe and efficient crane operation. Once the jib and counterweight are in place, the operator's cabin is installed at the top of the tower. This cabin is equipped with controls, communication systems, optimal visibility, and safety devices, allowing the operator to handle the crane with precision and confidence. At the same time, the necessary electrical and mechanical systems are installed to operate the crane, including those that control the movement of the jib and the rotation of the tower. These systems are connected and calibrated to ensure smooth and efficient operation. Before the crane is put into service, it undergoes rigorous testing to verify that all systems are working correctly and safely. First, load tests are conducted, lifting weights that exceed the crane's normal operating capacity. This ensures that the structure and mechanisms can handle the specified maximum loads without compromising their integrity. Next, a detailed inspection of all anchors and connections is carried out. Every connection point between the tower, the jib, and the slewing system is carefully checked to make sure they are properly tightened and secured. Any failure in these areas could compromise the stability of the crane during operation. The emergency systems, such as brakes and other safety devices, are also checked. These systems are essential for stopping the crane in case of a malfunction or emergency, and they must be in perfect condition to ensure the safety of the operator and everyone nearby. Once all safety tests are passed, the tower crane is ready to begin operation. During its use, a specialized maintenance team performs regular inspections to ensure that all components continue to operate safely and efficiently. In the case of cranes that climb internally, the weight of the crane is supported directly by the structure of the building under construction. This approach not only increases the crane's load capacity, but also reduces costs by eliminating the need for a longer mast. The process begins in a similar way, with the crane installed on a concrete base. However, in this case, a climbing section is integrated into the base of the tower, allowing for future ascents. As the building progresses, steel rings are installed within the structural framework, usually spaced 3 floors apart. These rings connect the crane to the building, providing support for a hydraulic jack inside the climbing section of the mast. When it is time to climb, the crane tower is detached from its base, and the hydraulic cylinder is pressurized to lift it. The hydraulic cylinder raises the crane until the base of the mast reaches the next steel ring. During this process, a ratchet system locks the crane in place, preventing it from sliding down inside the building shaft. This method ensures a safe ascent and maintains the crane's stability during high-altitude operations. This internal climbing system is especially useful in projects where space is limited or in high-rise construction, as the building's structural support provides significant advantages in both stability and operational efficiency. When the building reaches its final height and construction is completed, the tower crane is dismantled. A larger mobile crane is used for this task, or in some cases, a smaller crane is installed at the top of the building. This auxiliary crane helps disassemble the tower crane piece by piece, allowing it to be transported and removed. This process can take anywhere from several days to weeks, depending on the size and complexity of the crane and the conditions at the job site. And that is the entire process behind the production of these colossal tower cranes. What do you think of this process? Let me know in the comments. If you enjoyed the video, don't forget to leave a like and subscribe to the channel so you don't miss our next video.